Welcome to the second video of the time complexity series. In this video, we'll go more in depth on constant time complexity and why constants don't affect big O notation. Let's get started. So remember, big O notation, its formal definition is that it's an upper bound of an algorithm's complexity in terms of the input size. And O to the 1, which is constant time, means that the runtime of our algorithm is always the same no matter the input size. And let's take an example to show why this is. So let's just say we have a function that's named getElement, and it takes in an input argument, which is an array, and it just returns the second element of the array. So let's say that we have two arrays, and with list comprehension in Python, we can just create an array that is 100 elements long, and let's create a second array that is 10,000 elements long. So very different sizes, 10,000 elements. So if we call getElement on array 1, and then we call getElement on array 2, the result will always be the same because we're only getting the second element of the array no matter our input size. And this is why it's constant, because we're always taking constant time to access the array, and it doesn't matter if it's 100 elements, 10,000 elements, a million elements. It can be infinite elements, but it'll always take the same amount of time, and that's why we call it constant time. So let's move on to why constants don't affect big O notation. Remember, big O notation, it tells us a runtime based on the input size, and that means that big O notation is just the representation of our runtime. So O to the 1, it represents all of the algorithms that take constant time and does not depend on input size. So if you want to, like, a quick trick is that if an algorithm is not dependent on input size, it'll always take constant time, and its big O notation will always be O to the 1, no matter how many processes you do. So an example that we'll explain why O to the 10 is denoted by O to the 1. So let's say we have a function that says print hello, and then it takes an input, and then this just prints out hello world 10 times. You can kind of guess where I'm going with this, because see, this input is not used anywhere, so that means this part is not dependent on our input size, so it'll always print out 10 times. So let's see, let's bring down those two arrays from up top. Can't do anything right now. Okay, so let's call print hello with array 1, and let's see what it does. So you can see that it prints 10 times, and let's call it with array 2, and we can see that again it prints 10 times. So here we can see that it prints 10 times no matter our input size, which is why we say it's O to the 10, or that's like its very technical time complexity is O to the 10, and that's just to emphasize the constant factor of 10. But in theory, it's equal to O to the 1 because constants don't affect our growth rate of the algorithm, and O to the 1 just essentially means that our algorithm is not dependent on our input size, as you can see here. Thank you. I hope you learned something from this video.